In the movie Interstellar, the main character Cooper and the NASA crew journey into space to find a planet suitable for people back on Earth. But the satellite that supplies the fuel for the spacecraft has exploded, and only Cooper and Dr. Brand are left with not enough fuel to get back to Earth. Cooper decides to use the gravitational force of the black hole to swing the satellite Endurance back to Earth. To further help the spacecraft get back to Earth, Cooper sacrifices himself by detaching the Ranger he's riding on. Detaching from the spacecraft will lighten the mass of the satellite, which will help it to fly farther. Now, can Cooper survive the black hole? Dr. Romilly, a scientist studying relativity in the movie, claims that when you fly into a black hole at a high velocity, you can survive. How? Is this true or fiction? To answer this, we need to know two things. First, we need to know about relativity, and second, we need to know about black holes. According to the thought experiment by Einstein, an object traveling at near the speed of light contracts in size. According to Lorentz transformation, although it is impossible if you're traveling at the speed of light, your body will contract to zero width. Cooper in the movie is supposed to be traveling at near the speed of light, so he must be extremely, atomic scale wise, contracted. Now let's learn about the characteristics of black holes. We know that the closer we get to Earth, the stronger the gravity gets. Black holes have extremely high mass, which tells us that they have extremely high gravity. When a person gets pulled feet first into a black hole, he will see that his legs will stretch a lot. Why? Because black holes have an enormous gravity gradient, which means strength of gravity is different at different distances. Let's say you're falling into a black hole. Your legs are 15 feet away from the horizon, which is the center of the black hole, but your head is 15 away from the event horizon. Since the gravity gets stronger, the closer you get to the event horizon, your legs will get pulled by a stronger gravity than your head, which will make your body stretch a lot. This is called spaghettification, and this would tell us that no one can survive a fall into a black hole. When a black hole is smaller, the more dangerous it is. Due to the high density, space-time curves abruptly, which makes the gravity way stronger, which will eventually make your body stretch a lot in an instant and rip into pieces. Also, black holes spin at high velocities. The faster a black hole spins, the stronger the magnetic field surrounding it gets. If the magnetic field gets stronger, an extremely strong energy will be emitted, which would eventually melt everything in its surroundings, just like a microwave melts chocolate. So, can Cooper survive the black hole? Well, no. The black hole in the movie spins at a velocity 99.8% of the speed of light. This is unimaginably fast. Then extremely high energy will be emitted from the magnetic field of the black hole, melting him. If only the black hole Gargantua didn't have a strong magnetic field, Cooper could survive it. How? Won't Cooper stretch to pieces by the strong gravity because of the spaghettification? Well, we know that objects contract when moving at high velocity from Einstein's thought experiment. Therefore, if Cooper moves at an extremely high speed, he would contract. Then his contracted height will keep him from stretching to death. So, actually fly into that spinning black hole, Gargantua, is impossible. And so this scene is fiction. Right now, the particles that are bumping into Cooper's Ranger are dust particles swallowed by the black hole.